welcome everybody. It's wonderful to see so many of you here, and I apologize we don't have seats, and I hope you'll be comfortable enough to stand for this. Anyway, it's great to have you here for the School of Engineering's Vannevar Bush Dean's Medal Lecture. I have to put my glasses on because I can't see otherwise. I don't know if you know too much about the Vannevar Bush Dean's Medal, but we award this to an internationally recognized technological leader who has contributed substantially to the betterment of society through not only extraordinary technical achievement, but also significant contributions at the intersection of engineering and other fields, such as public policy, diplomacy, law, medicine, science, and social science. And we developed this medal in collaboration with Tufts Institute for Global Leadership, with Sherman Teichman, who's the director of IGL. And we renamed the medal in 2010 to honor Vannevar Bush, who is one of our most distinguished alumni of the School of Engineering. Vannevar Bush earned his Bachelor of Electrical Engineering here in 1913. And he went on to obtain a PhD at MIT in 1917, and in 1919 he was an associate professor at MIT and later became MIT's engineering dean and vice president. And he was elected the president of Carnegie Institution in 1938, and in 1940s given the presidential approval to form an independent agency called the National Defense Research Committee. And at the helm of that organization, he oversaw many scientific research programs during World War II, including the nuclear weapons programs that developed the atomic bomb. And after the war, Dr. Bush prepared a report to the president on ways in which wartime lessons could be applied to peace. And his work, entitled Science, the Endless Frontier, became the basis for what has now become the National Science Foundation. So Vannevar Bush is a very distinguished alum of our school. And now I wanted to tell you a little bit about Dick Frenkiel, who is also a distinguished alum of Tufts School of Engineering. 50 years later, in fact, you graduated. And you graduated from the Department of Mechanical Engineering. And Dick is here with his wife, Maisie, who is a 63 graduate of classics, is that right? Jackson
that's right.
College. And they met here, and they've been together ever since, so that's a great testament to Tufts.
Engineers are boring.
So Dick, along with his colleagues Martin Cooper, Joel Engel, Thomas Haug, and Yoshihisa Akumura, is that how you pronounce it, made substantial contributions to the cell phone's creation. Dick also got his master's in mechanical engineering from Rutgers University after he left Tufts. And then in the late 60s, he, along with Engel and the late Phil Porter, were the earliest engineers involved in planning for high-capacity mobile telephone systems at Bell Labs. And they developed a plan for a network of low-power transmitters and receivers spread throughout a region that came to be called cells, which allowed service to be expanded to millions of users with a limited number of channels. And that network resulted in the design which would become the first cellular telephone system in the United States. And in 1977, Dick became head of mobile systems engineering, and he served on the Electronics Industry Association committee that created the first standards for nationwide cellular service. In 1983, he left cellular to become head of R&D for AT&T's cordless telephone business, where he led the team in the design of the 5000 series of cordless telephones, and he's responsible for its early manufacture in Singapore. And then he retired from Bell Labs in '93, and then he joined the Wireless Information Networks Lab at Rutgers as a visiting professor, and I understand he teaches a course in wireless business strategy there. Dick Frenkiel has many, many awards. He received the Alexander Graham Bell Medal of IEEE, the Achievement Award of the Industrial Research Institute, and then he received in 1994 the National Medal of Technology, and the highest U.S. honor for technological achievement. And in 2013, he and his colleagues were recipient of the Draper Prize, the Charles Stark Draper Prize for Engineering, which is a National Academy of Engineering prize. And he's a fellow of Bell Labs and of IEEE and a member of the National Academy of Engineering. And I have one fun fact. I just understand that he served as mayor of Manalapan Township, New Jersey, in 1999, so you couldn't stay retired. So I'd like to welcome Dick, and he's going to be speaking to us on college and career vignettes. So we're very happy to have you here, and please.
Thank you. I have to. I don't need to. Thank you all for coming. I'm shocked. And there's one more seat here now, yeah. There's room on the floor if anybody here gets tired standing. I'm embarrassed. It's really, thank you, Dean Abriola. It's very nice to be back here after 50 years. I think my professors would be surprised. I know that Professor Vanna would. Did anybody here ever work with Professor Vanna? He wrote a recommendation for me for interviews. I got to see it a year later. I wish I had seen it earlier. It said, Mr. Frenkiel will probably be a fine engineer when he grows up. It annoyed me, but he had a point. So coming back here, I've done technical talks on cellular for many years. Coming back here for this awakened a lot of memories. Memories of being here, memories of career. And I found I wanted to talk about something a little different, to talk about the work we did in cellular, but to make that a context for the work that we do as engineers, for the careers we have, for what matters. Most of you are not going to work on electronics and communication systems, but whatever you do, I'd like to say something that matters. And so I launched into this, and I told the dean that I would do it, and she was encouraging. As I worked on it, I found it was very hard. It's hard to say things about what we do and what we care about without sounding pompous or, you know, I don't want to sound like granddad giving you advice, but I will. But it matters. Because if you think about it, the goal of all this is to have a good life, I think. And people don't think about that enough. They don't ask themselves, what do I really like? What do I want out of life? You take on goals that seem important to other people, you know, like being the vice president of something or starting a company. And for some people, those are excellent goals. But it's, I think, once in a while nice to think about these things, and so I want to talk about them. And I hope it works out. If it does, send me email. If it doesn't, send the dean email. So, to begin. Oh, and, I should say another thing. When I talk about this stuff, when I talk about cellular technology, I probably know what I'm talking about. When I talk about life, that's not truth with a capital T. That's my truth. And what I would encourage you to do is think about it. And if it seems true to you, great. And if it doesn't seem true to you, that's great too. Because if you just think about this stuff a little bit, I think I've accomplished something. That to spend a little time actually thinking about why you do what you do and what it is you love to do. So let me begin. The work that brings me here today began in 1966 and went on for 17 years at Bell Labs. And in that first year, there were two of us, Phil Porter and me. He knew what he was doing, I didn't. Well, no, actually, that's true, and it's important. Yeah, the bad stuff in the system is fine. So, within, say 5 years, the project that was the two of us, our work described a system. We were asked to decide if a system of this sort could be built and how it could be built and how much would it cost and what would the problems be and how many people could it serve and how many channels would, that sort of thing. And we came up with a proposal. And actually, our proposal isn't all that different from what emerged 17 years later. And we went back to the FCC with this proposal, and the FCC got interested, the Federal Communications Commission. And they got interested in providing channels. And we made a bigger proposal, and more people came on the project. And by the early 70s, when we started developing the system, we were reaching 200 engineers. And in 78, we had a trial, and it was the first cellular system in the world. We had 1,000 people, paying customers in our trial. And then a bunch of political things happened that delayed us. But in 1983, that system in Chicago became the first commercial cellular system in the United States. At that point, we felt like a success. But our goal, our real vision, was that we were going to create a nationwide network in the US owned by AT&T, a big monopoly system. We were going to cover the world with cells. And within months of our big victory in turning on our first system, they broke up the Bell system, AT&T, the monopoly. And it didn't get to do any of that. And so for us, it was a very bittersweet victory. Our system worked, but other people got to install it. And a lot of us who worked on it wandered off to do other things. And if you asked us then if we had succeeded, we would probably say no. Our dreams never came true. And then years went by, and some miraculous things happened with cellular, some really remarkable things. We thought, when our first system started, that in 10 years, we'd have 2 million customers. In 10 years, there were 50 million customers. We put our first radios in the trunks of cars because they weighed 15 pounds. In 10 years, they were in the pockets of shirts. And what was a car phone system had become a personal telephone, which is the way you all see it today. When we started our work, there was no internet. But in the 90s, there was. And in the new century, we have smartphones. And everything changed with that. I mean, talking's become a secondary reason to have a cell phone, right? People use them for entertainment. You can watch a movie on it. You can listen to music on it, read a book. You can do your banking. You can navigate your car. You can buy things. You can send messages to your friends. I mean, what happened there is the true convergence that had been predicted for decades, the convergence of entertainment, communications, and information, all in one thing. We never saw any of that coming. But suddenly, cellular was this huge thing, one of the great advances in the world. And they went back and looked and they said, hey, who started all this? And we became heroes. So, first question about, what's life all about? What does this mean? We thought we were successful when our system worked. We thought we had failed when the government broke up our company, which really had nothing to do with us. And then we became successful again when other people created smartphones and small phones. That's an interesting question. What makes us successful or not successful in our lives? And with that question, I'd like to propose an entirely different answer, because this first answer that, we're successful or not because other people bought the system or other people made it better, we became a success. What did that have to do with our work? So let me show you a different picture. This is part of the team that brought you cellular in the 1970s. Getting old. Few still working, though. We meet for lunch 3 times a year, perhaps. It's been a tradition. 30 years we've been meeting, so we must like each other. And if you asked us at lunch, how do you feel about what cellular's become? we'd say, oh yeah, it's very nice. Sure, it is nice. I mean, who wouldn't want to be worked on something and it became important? But there's no passion in that. But if you listen to us at lunch, we're telling jokes. We're remembering what was. And I think that says something. What was important to us was being there. It's not how it turned out. It was being there with a team that was smart and creative. It was solving problems that were really interesting. And it was having a dream of how it would turn out. And having the dream is different from how it turns out. So it seems to me that if there were a way that you could spend your life loving what you do every day and having a dream, it really doesn't matter how it turns out, does it? I mean, how much better can you do than loving what you do every day? The other stuff happens later. It's like I described it once as an epitaph written by strangers. You know, other people get to decide whether they like your system or not, or whether it even works or not. But if you've loved doing it, you can't lose. So that's the first sort of a thought that I'd like to offer you about what we do and what it means. So on that thought, I want to talk through the prism of cellular and memories. But here's what I thought I'd talk about. I want to start with the college experience. I have to. I'm here. And it's such an important part of life that I can't resist saying a few words about it. And then the world of Bell Labs. I want to say something about cellular. Why is the cellular system so important? Why does it matter so much? Probably most of you never even thought about that. The basic idea of cellular system hasn't changed since we worked on it in the 60s. It's gotten a lot more complicated. It does a lot of things it didn't do then, but it's really the same reason to have cellular. And then I want to talk about some things from my own experiences that seem important. The first is the importance of mentors. I had a mentor, made my career. Then I want to talk about this other problem, this being ignorant in a world of experts is a scary thing. And how you deal with that matters, I think. Then I want to talk about some classic mistakes that got made because people didn't take the time to look at a slightly bigger picture. Engineers have this problem, I think. A good engineer tends to focus. You could focus very narrowly. You do that, though, in some cases you can miss the bigger picture and make a big mistake. And then I want to finish by going back to this question. It's almost suggested by what I started with. What's a career about? What's a worthy goal? And you know, when you look back on your life, what will it maybe seem was important? Okay, so there's the plan. Let me start. College. I'm not going to say much about that, but what I noticed thinking about, remembering being here, was how vivid and trivial my memories are. I mean, there's not a lot of memories of class. I mean, that's why you're here, you learn things, you get a job and all that, and it's important. But what you really remember, you remember all kinds of silly little things, and you remember them vividly. And so, you know, it's funny, you get used to that, you say, so what, so what? You remember that, that's the way life is. But think a minute, why do you remember all these trivial things? And I have to believe that the reason is that what you're doing here for 4 years is going through an amazing growing up. I mean, I think I came here as a child. And when I left here, I was slightly more mature. But, you know, I could talk that down. But really, I got a job. I got married. I bought a house. I had kids. Raised them. They're good kids. I mean, something happened here. And if you ask, what is the environment that allows that to happen? I think it's around you. You're part of a student body that is smart, certainly, creative, probably, diverse. They plunk you in there and they say, find your way. Figure out what works for you. What are you about? And you make a lot of mistakes and you do some things right, but somehow in that process, I think something really remarkable happens for all of us. And it's, you want to thank the university for something, is bringing together this environment to allow you to grow up in. That's how I remember it. So, my memories of being here, and every single person here are going to have entirely separate. All these memories are so individual that no two people will have the same ones. But there are some commonalities. I have a lot of good memories from here, and I have some things I really screwed up. And I'll give you just one example, bad example, because it leads to an important message. The most ridiculous thing I did here in 4 years was oversleeping and missing my interview with Bell Labs. And I hate to say this, but twice. I don't know how that could. Well, you know, I tended to stay up late, and I got used to sleeping late. It's very hard to break habits like that. So the second time, I ran down to the interview. You know, I was so embarrassed. Put on my interview suit, didn't shave, didn't have time. And when I got there, these two guys, young fellows from Bell Labs, were leaving. Their coats were on, they had their attaché cases, they were leaving for the airport. And I blurted out an apology. And one of them looked at the other one and he said, "What the hell, we got 15 more minutes." And in that moment of incredible grace, charity, they changed my whole life. They don't know that, but they changed my whole life. And the message in that is, I think that happens all the time. We do things all the time, and we have the power to change a life for better or worse. And it's a good thing to remember. So, through that little bit of grace and charity, I did end up at Bell Labs. I discovered at Bell Labs that it wasn't a great place for a mechanical engineer. I mean, it's a very electronic place, and what seemed to be the more important work was done on communications. They had me designing recording machines to tell you the time, you know, at the tone, the time will be. And it was okay, but I wasn't even very good at it. I'm a pretty sloppy designer. And I like ideas, and I'm not so good at doing the detailed work. So 2 years in, I wasn't having a lot of fun, and I wasn't sure I was going to stay there. And then, by the way, an important thing, you just hang around in some companies, things change. People change jobs because they don't like what they're doing, and they want to find something better. Whether you're doing something you like or you don't like, they're going to change your job. So if you hang around a while, it's a fairly efficient way of changing jobs. So one day, there's a reorg, and I get a new department head, and he calls me in, and he says, "I want you to work on this thing, this radio system, and come up with a plan for it, because we think the FCC could be persuaded to give us some channels." And I'm sitting there thinking, does this guy know I'm a mechanical engineer? Does he think I'm someone else? But hey, it sounded interesting. And I said, yeah, sure. Thank God he assigned me to work with another engineer, a really good electrical engineer, physicist, PhD. His name was Phil Porter. And Phil was a teacher. Phil enjoyed answering questions. Any stupid question I had, he answered it with a straight face. He didn't laugh at me. He said, "Oh, that's an interesting question." And if I had an idea, he didn't say, "Well, you know, that's kind of an ignorant idea." He treated my ideas as though they mattered. He was a wonder. And because of the way he was, I was able to contribute, knowing very little, but knowing more every day. And over the months and years, I got to be pretty good because he allowed me to do that. And so he was my mentor, and I owed my whole career to him. So we produced the system, and in, no, let me go back. We're talking now about the system, and I want to spend a few slides to at least give you, for those of you who came here thinking you were going to learn something, I want to tell you something about the system. When we started our work, there were radio telephone users in the US. The systems were very simple. You put a transmitter and a receiver on top of a hill, and they had a lot of power, and there was a lot of power in the car system, and you could talk maybe 10 minutes. So here we are on Radio Hill in San Francisco, if anyone recognizes it. And everything you can see there is part of our system. And we probably have about, 10 or 15 channels. And each channel we have can be used by one person at a time in this entire area. So there can be 10 calls working here. Yeah, you get that, huh? With that system, here's the Northeast Corridor. Boston, Hartford, New York, Philly, Washington, and some other smaller cities around them. The big cities, there are 50 channels here. The big cities get half of them. So it's 48 actually, 24 in the big cities. The other smaller numbers are scattered around in the smaller cities. What you are seeing in this picture is the potential for 200 calls in the Northeast Corridor. There's got to be more calls than that on this campus right now, right? So that was the problem. Car telephones existed. There were few channels available, and the way the channels were used did not allow many calls. So what was cellular about? Here's Radio Hill in San Francisco again. And if you cover this region with a lot of cell towers and create small coverage areas like this, then the channel you use in this coverage area can be reused in this one and that one. In effect, by using small coverage areas, you get to multiply the calls that can be handled by whatever number of channels you have. That's what cellular is about. That's what gives it all its advantage. Now, making the system has a lot of problems. You have to locate the car. You have to know when it changes cells. You have to switch to new channels, run the call through a new cell. You have to do that, retuning channels in the mobile. All that has to be synchronized. And the customer hears maybe, and that's all. There's a lot of problems that come. The problems of managing this system were huge. In fact, what this system is about primarily is not radio. It's about software. It's about signaling and switching and control. And those are the technologies that were emerging with some power in the 60s and in the 70s. The first microprocessor, Intel's, went into our first cell phone in the car. We needed the logic to control how the system worked, how the car could communicate and interact with the switch. So this is what cellular was about. That's it. Since that time, there have been many advances. Cellular systems were relatively simple in my time. They have become extremely complicated. Some of the math going on, the digital processing going on is you need to be a mathematician today to work on some of these systems. But basically, what remains is small cells multiply capacity. So a big system might look like this. The smallest cells in the middle, bigger cells where there's less demand. Okay? So a system like this, using systems like this, we're currently serving about 300 million people in the US, more than 320 million actually. There's a cell phone today for every person. There's a cell phone today for almost every person in the world. We've got 6 billion cell phones in the world. They're being used in some remarkable places. I mean, it blows my mind. The idea of a Kenyan fisherman on the cell phone, on the smartphone, looking for the highest price for his catch on his way back into port. And how about those people in Tehran, organizing against the government because the government's having trouble shutting them down because they're using cell phones and Twitter. These things are amazing. But what you've got here, those 300 million people in the US, compared to before we started with those 50 channels, there were about 50,000 customers in the US. So we've increased, and we're talking about 4 times as much. So we've increased the capacity for these people by a factor of 24,000. Where did that come from? 40 times came from more channels, more spectrum. 10 times came from technology, like digital radios, like voice compression. And 60 times came from cellular reuse. So for all that's happened, cellular reuse remains the big advantage of cellular. It's still why these systems can do what they do. Returning then to my early days, to my ignorant days on cellular. This is the guy that taught me all I needed to know. And as I said, without him, I would have had no career in cellular. But he wasn't just my teacher, making it sound like I did all this stuff thanks to, you know how you thank your teachers for teaching you stuff. He was a brilliant engineer on his own. When you use your cell phone, dial, send, that's his invention. And the reason for that invention was that we saved 15, 20 seconds on average by not using a channel when you were dialing. And it was safer because if you were in a car and you wanted to break off dialing in the middle, it didn't drop your call. That's Phil's invention. And when you look at a cell tower and you see those strange antennas at the top, the large antennas, they're directional antennas. And cell systems are reduced in their capacity by interference, and directional antennas reduce interference. That structure of 3-way directional antennas doubled the capacity of our system, and it was Phil's idea. And Phil never won an award. And I think about that. You know, I've gotten several very nice awards for doing this work. But when I get one, I have to say, what about the 200 people I worked with? You know? And what about Phil? And so, to some extent, I've learned to take with a grain of salt the how it's given out. And I've learned to depend more on that idea I raised. The good thing is that we loved our work. Whoever got the damn medal, we all loved our work. That second issue, living among the experts. You know, it's a difficult thing about engineering because we respect expertise. Everyone wants to be really expert in the things we do. And yet, we start out, we're not. So how do we deal with that? What happens when you go to a meeting and they're talking about stuff you really don't get? What do? You hide in the corner and say, I hope nobody notices? And by students, doesn't this happen all the time? You sit there in class and the professor says something, you have no clue. But you know, you don't want to raise your hand and look stupid. So you figure you'll ask a friend. And you leave the class and you ask the friend and they say, I have no idea. And it may be no one did, and no one asked. So I had this problem. You know, in the earliest days, I had Phil, and I was good with him. You know, I could ask him anything. But then the project grew, and suddenly I had 200 people, and some of them were really good radio people. We had radio experts we brought in had been on Kwajalein Island designing our anti-missile defense. And they arrived and they got thrown into cellular. And I'm at meetings with them, and I still don't know a whole lot about how radios work. I mean, I understand what they do and how to design a system with them, but I couldn't design one. And I'm sitting in meetings with these people, and they're saying things I don't get, and I have to decide, am I going to ask or not? Because when they came in, I was sort of the expert. You know, they were told, these are the guys, Phil and me, we designed all this. They expect us to be smart. Do I want to sound stupid? And I eventually concluded there really was no choice. I mean, if I said nothing, I was going to learn nothing. And so I'd go into meetings and I'd say, what do you mean by that? And wait a minute, if I understand that, then wouldn't this be true? And why can't you do it this way? And they'd answer a question. Most engineers, Phil was absolutely great, but most good engineers love to teach. And most of them will respect a question. There are places, though, to be brutally honest, there are places where people are brutal. Bell Labs Research was such a place, I'm told, where, you know, if you gave a talk and you showed ignorance, they would jump all over you. But the people I worked with, the people who designed things, were generally very good about answering dumb questions. And my favorite moment was a meeting with half a dozen, you know, a meeting that looked much like this, talking about the system and what kind of radio channels we should use was the subject. And what did we have to know about those channels? And I kept asking questions. And at the end of the meeting, this one guy, good friend today, brilliant guy, top mind, came over to me and said, I want to thank you for coming. You were a tremendous help. I didn't know what to say. I didn't know what he meant. First I thought he might be kidding. But he was a good guy, and I don't think he was. And I think what he meant was questions make people think, and the more they think, in telling you why your idea isn't going to work, they've still thought about something. And it matters. And so to me, as scary as it may be, you are most creative often when you're most ignorant. And as you start to ask questions and learn new things and say, well, wait a minute, then if that's true, won't this work? You're at your best. And to give that away by being afraid to ask is a big decision. It's one I wouldn't make. So I call that the power of ignorance and curiosity. What I have found, by the way, is that in management, particularly corporate management, you often run into what I would call ignorance and arrogance. And ignorance and arrogance combined with ambition. Whoa. But ignorance and curiosity, that's a powerful thing. So, next issue. What is this thing about not seeing the big picture? I want to start with a classic mistake that I made. By the 1970s, what we're trying to do is convince the FCC to give us all the channels. There's about 1,000 channels. And I understood the system, and I understood economics of the system. And cellular systems have a peculiar economics in which, if you double the number of channels, you almost cut the cost of the system in half. And wow, that makes the service cheaper, and you're going to have a bigger market, and who wouldn't want to do all that? The only problem, of course, is that it means the system's a monopoly. Well, we were good at that. We were a monopoly. We liked being a monopoly. So I got very arrogant on this question. To me, there was no logic to not giving us all the channels. And what I couldn't understand, for example, I said we had our trial in 1978, and years are going by, and the FCC refuses to make a decision. And I'm writing all these papers and I'm saying, you must give us the channel. There's just no, splitting the channels is ridiculous. This stupid thing called competition. So, nothing's happening. And one day a good friend of mine who worked in what's called Federal Regulatory Liaison, he calls me in and he says, could we, you keep saying we have to have all the channels, could we design our system with half the channels? Is it really economically infeasible? And I started with my rant, of course. It said, if it's not, you know, and he listened to my rant as he had in the past. And then he said, well, so if we can't do the system at all, you're okay with that? And I said, huh? And he said, well, don't you understand? Monopoly is on its way out. To give us a new monopoly politically is impossible for the FCC commissioners. You give them the only choice is to give all the channels to one person, and they're going to find ways not to make a decision for years. So I said, oh. Looking at it that way, I went back and wrote a new white paper. It was okay. We could split the channels. And the problem went away. And the FCC was willing to act because now there was going to be two competitors in every market and it was no longer a monopoly. Now, of course, it worked out badly anyway because they killed AT&T. But at the moment, that was a big breakthrough. And it taught me, you know, here I was the big expert. I've been working on cellular for more than a decade. I was an expert in the system and I was an expert in the economics. And I forgot about the politics. And when you miss something like that, you can really get screwed. Two other issues. In the 1990s, new digital standards. We got digital cellular phones. Used to be analog, became digital. Two standards were proposed. CDMA, Qualcomm system. TDMA, Ericsson. They fought and fought and fought. Something we had done in the early days on cellular. Oh, I'm right, you're wrong. And when you do that with a complicated issue that people aren't really going to understand, they just get scared. What these two companies missed was that if you scare the customer doesn't have to buy anything. What was worse than that was the Europeans came out with GSM. GSM had nobody yelling at it. So the world, you know, if somebody wanted to buy a system, well, if you bought GSM, there was nobody telling you you were wrong. But if you bought either of the two US systems, you were going to be wrong. US lost a lot of market in those years. A lot of the world went to the European standard. And the lesson in that is, when you're arguing about highly technical things, trying to persuade people about things they don't understand, you're likely to turn them off. The third issue, which is happening now, the third generation systems that access the internet. All that you kept hearing about, and you still do, what do they talk about? What's the figure of merit in a 3G, or now they say 4G. 4G is 3G. I mean, that's marketing. But they're really basically the same, all these systems. They're better than the 2G, a little bit, maybe twice the capacity. They've added a little bit to efficiency. What they'll tell you every time you turn, it's how fast can they download. They'll be telling you, oh, our system downloads faster than their system. In the companies that set all this up, they didn't bother to say, what's the capacity of the system going to be? Not how fast can it download. You can always download faster by giving more of the spectrum to one customer for a while. But what's the capacity of the system? In fact, it had not increased very much. What was it trying to download? Movies. What's the size of a movie? Roughly the same as 6 months of talking. So they told people, go out and do whatever you want. Unlimited service. That was the first offer, right? $50 a month or something, unlimited downloads. What happened? People start downloading video, and the systems crashed. I don't understand to this day how the people who built these systems could have focused so heavily on the speed of a download without asking how many people could do that. But they did. So, in particular, this third thing, the message I have there is, you would assume, you would look at this, perhaps as an outsider, and say, well, they must understand that. They can't be making such a stupid mistake. They can. You will work for companies that may make very stupid mistakes. And in fact, if you try to tell them that, they may not appreciate you. But if they don't understand that, they can also destroy their companies. So there's something worthwhile in understanding all the aspects of what you're working on, not just the particular problem you're trying to solve. So let's finish this with a discussion of careers. We start our careers with some predictable goals. Many people, well, some people like the technology. Many people want to be the president, the vice president, or at least the supervisor or something. People have a tendency to want to get promoted and make more money, and it's understandable. And I'm not here to tell you what your goals should be. But I want to mention my own experience in this regard. Because early in my career, I was doing pretty well. I was regarded highly for the work we had done on the first system. And people, I had a guy once ask me, one of the people above me said, how high do you want to go? And I had no idea, because that was a question that actually didn't interest me that much. But at some point in roughly 1977, I really wanted to be a department head. But I wanted to be department head of systems engineering in cellular for what I think was a good reason. I was getting tired of the smaller problems. I wanted to contribute to strategy on a larger scale of how that system was going to work. But I still wanted to be connected to the work. I wanted to meet with the people who were doing it. As a department head, you've got some supervisors, you've got maybe 50 engineers. You can know everybody. You can be aware of what everyone's doing, but you get to play with bigger marbles. And I wanted to do that. And I got it, and it was great. Later on, I started to say, well, I ought to want to be something more, shouldn't I? I'm supposed to be a director next. And that didn't come so easily, and I started to worry about that. But I didn't then have a good reason for wanting to be that. That was just to be something more than I was. Well, I went from cellular in 1984 to the telephone business. Very different business. Consumer electronics, cheap phones, manufacture in the Far East. Very, very interesting problem. Very interesting. Trying to turn around a business unit that's losing money, trying to figure out how to manufacture cheaply, where do you buy your parts. There's a lot of really interesting stuff, very different from cellular. It's sort of like low tech, but very cost related. So, I went off to cordless, and I screwed things up badly for 2 years. We had a project, we were way over cost, we had to cancel it. I'm surprised they didn't throw me out. And then we got smart. And 2 years later, we had the best phone in the US, and our costs were good, and we were suddenly, from losing money, we were making a lot of money, and we had 50% of the market of the United States. We were doing really well, and now I'm a hero. In fact, they make you a hero because they need a hero. Here's a company that used to be a monopoly, and now it's fighting for its survival. They need people that they can point to and say, see, we can make it in this competitive world. So they liked me for a year or two. In that year or two, they had this thing called Project Miracles, where they sent organizations out in the woods to jump off cliffs and be friends. You've heard, what is that called? Outward Bound? Outward Bound. It works, it really matters. You jump off a cliff with somebody, you get close. Briefly. No, it really was an emotional experience. It really brought people together. So I'm there with my department at a place called Gold Camp in Colorado. Beautiful terrain, up on a mountain. And we're doing all these things, and we're feeling incredibly close. And my boss calls me up in the middle of that, and he says, the president of Consumer Products wants to make you the head of the cordless business, not the cordless R&D, the cordless business. That was a very strange offer to make an engineer. They didn't normally do that. So in a way, this was my moment. You know, if you want to be somebody important, whatever that means, sometimes the moment comes, and you're supposed to seize the moment, right? Carpe diem. There I am with these people I love. And it was a difficult moment. And I thought about that all the rest of that day. And the next morning I went out to this, they had this vision point, you know, the place where the Native Americans used to go to have the vision of their life. You stand on a high spot and you look out and there's a mountain. It's really, you feel yourself drawn into the world. And I sat there and thought for a while, and I went back and said, no, I don't want to do it. Part of what I thought about was, we, the engineers, we cared about what we were doing. We were these foolish people that instead of worrying about our careers, worried about making a good product. There are people at headquarters that thought that was funny. Like, what's the matter with you people? You're supposed to worry about getting promoted. You're not supposed to worry about someone else's problems. And I realized I didn't belong there. Powerful thing to realize something like that in your life. It changes you quite a bit. And I knew, at least for the next few years that were the rest of my career, that I was going to stay where I was. Other people have told me you're an idiot, that you know, that was your moment, you should have taken it. I don't think I was wrong. In part, I don't think I would have been successful there. It's not what I wanted. Now, part of the story, though, is you can't keep things. You can't decide to bury yourself in a particular assignment because you love it and it's going to last. Nothing lasts. So 5 years later, I'm fighting with management. I have my problems with the way AT&T is being run. I didn't have a right to have problems with AT&T. I was too small. But I did. And I wrote letters, and I didn't like the lack of cooperation, the lack of strategic planning for engineering. And they finally said to me, you know, well, why don't you leave? And I did. I left very sad because so much of my life was spent there. Bell Labs mattered to me. And suddenly there seemed nothing else to do but to retire. It was a very sad moment for me. And you know, if you think about it, because I'm standing here and you know, they tell you that I did all these great things, you can do those things and feel like you failed. I started thinking about my career and I thought, you know, our dream was to have a nationwide network. That was the monument to our success. Never happened. Our dream was to have this cordless business. And 5 years after I left, it was losing money and they sold it off. It seemed like nothing I had done mattered. And it was a pretty sad moment as I was leaving the company. And it made me think. It started me on the path of thinking about all the things I've told you today. What is it then that makes you a success or a failure? And then I remembered a few things. First of all, your life just isn't just about your job. And it's good to remember that because people who think it is make some pretty bad mistakes in the rest of their lives. But also, I remembered this. That's a picture from 1977, a picnic, cordless, at the Cellular Systems Engineers. And I remember going outside with a friend at lunch, and we're walking around the building on a pretty day, and I said, you know, if I won the lottery tomorrow, I'd still be coming into work because there's no place else I'd rather be. And that turned around my thinking on what life is about, and I stopped feeling like I had failed. When I got the Draper Prize, the 4 other people, they elected me to speak for them in receiving the prize. And I was thinking of Phil Porter, who had just died without receiving such prizes. And what do they mean? And what does all this stuff mean? And I wanted to say something that mattered about our work. and I finished. They gave me 3 minutes. And it worked okay. I finished with this, that for an engineer, the perfect life is to work with brilliant, creative colleagues on problems that are interesting and important and difficult. And to dream that your work's going to change the world. The rest doesn't matter. I wish you that. Thank you.
We have some questions. Are you willing to take some?
Sure. Yes.
So what would you say was your true motivation to work at Bell Labs?
I was very young. I didn't sign up for that interview. And the head of the employment office, Mrs. Saltmarsh, called me up. I had good grades. I was a fairly lousy student in many ways, but I did have good grades. And she said, why haven't you signed up for Bell Labs? And I said, I'm a mechanical engineer. And she said, that's okay. They'll pay for your master's. They'll give you time off. They're the creme de la creme of companies. I thought, well, how could I not? You do things, I mean, it'd be nice to think that we do things for well thought out good reasons, but no. Yes.
A couple questions. One was, when you were looking at the cell system originally, what about the competitive technology, which was called Iridium, the low Earth orbit, 68
Okay.
satellites? And the second question is, did you ever feel like you worked a day in your life? Does it work?
Yeah. Okay. It varied. I mean, yes, there were days when I just had to go in. It was just so much fun. And there are days I once guessed that I loved my work 3/4 of the time. I mean, I don't think it's going to get any better than that. I mean, if I made it sound better than that, nobody's going to love going into work every day. But if you love going in most days, you're doing pretty well. Iridium was not a competitor of ours. Iridium is a 20-year difference. When we did this, Iridium came along in the 90s. We were doing our work in the 60s and 70s. Iridium was a classic mistake. Iridium was Motorola's thing. I was told that they put $6 billion into, which at the time was a lot of money for a non-government. Iridium could not possibly have had the capacity. If you think of the issue as being cells, the cells created by Iridium, the antenna with 50 sub-antenna, an antenna from a satellite passing over 400 miles over your head, covered the US. And it had 50 sub-beams. So a beam is about a state. So reuse is from New York to Virginia. It's not 100 times in New York. So Iridium was about reaching difficult areas. It was about no place in the world is not covered. You know, if you were a CIA agent, you'd want an Iridium phone. If you were at the South Pole, that's what it was for. And that's why it hasn't died. It went bankrupt in 6 months, the Iridium project. But it didn't go out of business. Systems, you know, if somebody's willing to buy it. Iridium got bought for half a cent on the dollar. And it's still working today because it serves a purpose. Yes.
So you seem to have kind of stumbled into a job that you just synergize with perfectly by random happenstance. For those that still really have no idea what they want to do, is there anything that retrospectively you see as like a beacon or anything? Was that clear?
Oh, yes, clear, difficult, clear, but difficult. Yeah, I think you've got it right that I've been lucky. I mean, I didn't ask for cellular. I have to believe that, but cordless was very different than cellular, and I had a great time there too. I have a feeling that if you're working with good people and the problems you're solving are interesting, and you think you can accomplish something, you have a dream, I think you're going to love your work. At the time I was working on cellular, there were two other big projects that passed through Bell Labs. One was called Picture Phone, total failure. One was called Net 1000, which was AT&T's version of the internet, flawed. Good engineers, cared about their work, probably enjoyed their work sort of like I did, but never got to see a success. Is that a problem? They may. They worked with good people. They solved interesting problems. They had a goal. Didn't come true. But the come true is later. All the time you're doing the work, you're dreaming. You don't know that it's going to fail. So I think there's an awful lot of jobs. And all I can say is that if you're working on something and you don't feel good, then you should probably find something else to do. But it probably isn't the technology that will make you feel that way. Maybe the people aren't so good. Maybe the company isn't so good. But there's an awful lot of good things. That's what I'm trying to tell you. It's not about winning a medal. It's not about the dream coming true. It's just feeling that good feeling every day. Yes?
With regards to noticing the big picture, is that something an individual engineer is even capable of, or does that require hindsight, collaboration, or some other interesting insight?
Yes, some of my best sight is hindsight. You notice I'm picking these things out after a whole career, so maybe I'm missing the ones that wouldn't have made my point. You're not encouraged as an engineer to do more than your project. You know, your tendency is toward narrow focus, and your incentive is toward narrow focus. We give you this to do, you get it done. What I'm saying is, and by the way, for many engineers, maybe that's okay. Maybe you don't have an interest in the bigger picture. But I think that the more you make yourself aware of what's going on around you, the more interesting your own work becomes. And once in a while, I mean, I got to tell you, this question of the lack of capacity of the 3G systems, I got a chance at WinLab. We invited in people who ran those. AT&T was there, Verizon was there. And I said, you guys aren't going to have the capacity to provide the service you're claiming. And they patted me on the head. They basically said, no, you don't understand this new technology here. I did understand, and they didn't, but they paid a price for that. So, I don't know. That's perhaps the weakest of my advice. I'm just saying, I think it's good to have a broader picture of what you're working on than the thing you're working on, whether or not you spot the big problem. Yes?
So you mentioned the capacity problem, and obviously we still have work to do because we can't download videos, all the videos we want on our phones. But do you think there will be a point where the demand for bandwidth saturates?
Well, one thing that's happened in the last 20 years is there's been a lot more bandwidth provided. When we started, there were no channels for anything. The top of the spectrum was at 1 gigahertz. They had just opened the top half of that. So, you know, they couldn't build cheap radios at higher frequencies. Now they can. So now there's 10 times the frequencies that there were when we did our work. There's a lot more spectrum around. What I have said, and in fact, in my class, our class project is to design a system to solve this problem. What I think the answer is, and the cellular companies are starting to do it now, is Wi-Fi. It's spots of intense coverage that you can pick up big files from. my contention is you shouldn't be trying to download a movie. You don't need to download a movie while you're driving. You can download it when you pass a particular spot. When you're talking, you need continuous connection. Like, conversation's kind of hard without continuous connection. But when you're downloading a movie, you do it at a stoplight. So to me, the real capacity in our country today is in Wi-Fi. Everyone's got one. I mean, just think of other people own it and they don't let you in, sure. But think about just driving down the street. Every house you pass has a 50 megabit download you could be using, and it's free. Those things. Our base stations cost $1 million. Wi-Fi costs, what, 50 bucks? And it's got more capacity than a base station, a cellular base station. So I think the answer is in downloading the things that need to be continuous through the cellular grid, downloading the big stuff through spots like Wi-Fi ports. Yes?
Do you think that the sense of success and accomplishment that you got without necessarily the awards you received or achievement or recognition is as possible in an engineering career that involves less research and is more routine?
Why are you asking the question? Just elaborate. Is it because you think it's important to get that? Because my answer would be partially, who cares? I mean, I'm glad I got the award, but I was okay before that. That's what I think I'm trying to say. But ask your question again.
A lot of the things you talked about, your greatest senses of achievement seem to be through doing the research with your peers. And so even if you hadn't gotten those awards, you would still have been happy through your own, say, personal breakthroughs. And I don't know if that is something that's as possible in the job where you're doing the same things on a day-to-day basis instead of getting to work with new things every month or so.
Yeah. Okay. And yes, the first part of what you said is absolutely true. If you think about it, I didn't get any awards until years after we finished our work on cellular. And I thought it was the greatest 17 years of my life. So I didn't need that. Now the question, yeah, most things you do don't win awards. I mean, that's the nature of it. I think that that's why it's not a good objective to have. It's a waste of time. And then the other objectives, like getting promoted. I know people who spend their whole careers frustrated because they want to be one step higher than they are, whatever step that is. There are things that don't bring a lot of happiness, I think. And again, I want to say to you, this is my truth. It's not the truth. I'd be happy to hear from, you got my email address. I'd be happy to hear if you, and even, years from now. This is not magic stuff. My feeling is that it's a lot easier to be happy about what you're doing. And I do believe you could be happy about all kinds of different work. I mean, by the way, at one extreme, I was thinking of saying this. You work on a cure for cancer for your whole life. And you believe in what you're doing, and you love it, and you fail. Well, you're a big failure. You've loved every day of your life, and you're a failure? No. So there are so many ways that you can love your work, and it doesn't require a cellular system. Like I said, the cordless job was trivial technology, but there was interesting things about it. We needed to make money. Making money's hard. People lose jobs if you don't. You can always find something about your work. If nothing, just to be the best company at whatever you're doing, to come up with a breakthrough in some way, make it cheaper, make it better. I really believe that. Engineers are lucky. We work on things that we have a tendency to care about and be interested in. And engineers, the people at headquarters I knew were very focused on getting promoted. They once asked me, in my cellular department, a new guy came in from headquarters and he said, I want to know how many people, what's the average years they've been with you and their average experience in total? And I took the survey and I came back and I said, wow, my people have an average of 15 years experience and an average of 9 years on cellular. And I thought he'd say, wow, what a resource. And he said, what's the matter with you people? He said, you're supposed to change jobs every 18 months. He didn't even say what kind of job. Just do something every 18 months because that's the way you're going to get promoted. And those people feel sorry for us. Like we're some kind of, we're missing the boat. And I feel sorry for them because engineers have the tendency to get involved in what they do and care about it. And so they have a good step toward achieving in many different jobs what you're looking at. Okay? Yes.
Joe, you mentioned the moment earlier when you thought you were being taken for an electrical engineer. So do you feel like your whole life you've remained a mechanical engineer? Or
No, I can't say that. I'll say two things. One thing is that a lot of what you learn as an engineer in your 4 years, the math stuff, the physics stuff, and all, the stuff that makes you broader, that's really useful because even if you work in your right field, you're going to have to learn stuff 10 years from now that you don't know now. So the kind of an education that makes you good at learning is really what you care about. I spent those 17 years as a systems engineer. I thought being a mechanical engineer was a good step toward that because I've always believed that mechanical engineers liked to visualize things and how they interact. And so I felt like working on a system. The system is things, cell towers and wires and radios and cars, and that's a mechanical sort of a vision. So I felt that mechanical engineering gave me a good step toward being a systems engineer, but not knowing the radio stuff was definitely a disadvantage. Took me a long time. I don't know if I ever really.
I think maybe one more question.
Okay,
Sorry
well.
yeah.
So just given the amount of success that came out of Bell Labs with your work and the modem and all these things, how do you see the situation companies like Google is in with the way they can attract all sorts of talent with machine learning and artificial intelligence, and if, say, some of their projects like the Google Brain take off, and how that should be handled? And then also, what kind of stuff did you get involved in while you were here? Greek life, sports?
Okay, I'm sorry, the first question, you derailed me with the second one.
In general, and Google specifically.
I think that's great. I mean, I have a lot of old friends that mourn the loss of the monopoly. And truly, Bell Labs is no longer Bell Labs. I mean, it has the name, but it's not Bell Labs anymore. But the work going on in Google is a perfect example. We have learned, I think, my answer to these people is you don't need a monopoly to do great research. Boeing does great research. Google does great research. Innovation happens in this country, and it doesn't require what we did. I was in a fraternity. I had a great life here. As I said, I wasn't the great student, but I learned a great deal. Okay, I'm sorry. I'm going to finish you with a really quick story. My favorite moment, my heroic moment, because I gave you my worst moment. Our fraternity had a Parents' Day coming, and we built a barbecue pit. And we ran short of cement blocks. But we knew where to get them because there was a building being built on campus. This building! And at 2 o'clock in the morning, we snuck over here, maybe 10 of us, and we took a bunch of cement blocks. They're heavy. And we carry them up the hill. And there's no library there at the time. The hill is open. And on the top of the hill is a road, and the road curves down to Professor's Row. You could drive on it with real people. And we're going up this hill. It's 2 o'clock in the morning, and we're walking up. And as we get near the roadway, down on Professor's Row, a campus cop car turns into the road coming up the hill. And the people I'm with say, my God, what are we going to do? And I said, in a moment of inspiration, drop the blocks and sit on them. And the headlights swept across us, and the car stopped. And this big cop gets out with his light, and he shines his light on us. He says, what's going on here? And I said, well, you see, sir, we're fraternity pledges, and the brothers told us we had to sit on these blocks all night. And he said, no way, get out of here. And I said, these blocks are very heavy, sir. Can we leave them here? And he said, no way, take them with you. Thank you.
We have one more medal to add to your collection.
Thank you.
So we very much enjoyed having you, and this was a wonderful, inspirational talk. And I hope somebody in the audience 50 years from now will be back receiving the Dean's Medal and telling us about all the wonderful things that you've done. And,
I hope I'm in the audience.
And the great life that you've had. So I just want to...
Oh, wow.
So, I just wanted to acknowledge Sherman Teichman because he wasn't here in the beginning. This is he helped us found this medal, and so we mentioned you at the start. But we very much are glad to have you here. Everybody, there's a reception after this as well, so please stay and have some food. I think we may not have enough, huh?